Chapter 9, Chemical Quantities and Reactions. Section 9.1, Mole Relationships in Chemical Equations. So after this, go and check out video problems number 41 and 42. So the big thing you got to know about this chapter, so this is the stoichiometry chapter. So if you look up any other videos, you want to get some more help from someone else, stoichiometry is what we're going to be talking about and doing here. So we can go from grams to moles, and then we can go from moles to grams. We already learned that. That's not a problem. We can do that. Now you're going to learn how to go from moles to moles, and that's moles of compound A to moles of compound B, which is a completely different compound. Okay, and that's the only new thing in this chapter for the most part. All right. Now, the law of conservation of mass, which is very important to know. Matter cannot be created nor destroyed. Mass cannot be created nor destroyed. There is no change in the total mass of the substances reacting in a balanced chemical equation. Okay, we're talking about chemical equations here. So that means the total mass of the reactants equals the total mass of the products. Take a look at this balanced equation. We have CH4 reacting with oxygen, so it's a combustion reaction. On the product side, we have carbon dioxide and water. Okay, if I add up 1 mole of methane, CH4, which is 16 grams, 2 moles of oxygen, which is 64 grams, that's going to equal 1 mole of carbon dioxide and 2 moles of water. So law of conservation of mass, the mass before and the mass after are the same. Now the deal is you have to capture everything. So these gases that are given off, well, we'd have to capture those gases to be able to weigh them. We would only be able to use a certain amount of oxygen. So there are some caveats here, but for the most part, mass of the reactants has to equal the mass of the products. And we show this, we already learned this in the balanced equation. All right? Now here's the new part, the mole to mole factor. Since reactants and products have to have the same number and types of atoms, we can write what's called a mole to mole ratio or a mole to mole factor, which shows the relationship between moles of one substance and moles of a different substance. For instance, let's take a look at this 2 iron. I'm going to bring it down here real quick, just write it a little bigger so I can write some things underneath it. Okay, so what this balanced equation tells me is if I take 2 irons, either 2 atoms in this case, or 2 moles of iron, and I react them 100%, I'm going to form 1 mole of Fe2S3. Or 2 moles of iron will require 3 moles of sulfur. So that's the mole to mole ratio. 2 moles of iron for every 3 moles of sulfur. And so we can use that in this case to convert from sulfur to iron. And that's the only thing new for the most part in this chapter, that mole to mole relationship. I think once you look at those video problems, you're going to be fine with this. But as always, if you have questions, go to the discussion board, post some questions. You want to see an extra video, get it on there and I'll see what I can do. All right. Next video is section 9.2.